Hi guys, in today's video I'm going to be continuing with the AP Calculus BC syllabus. I'm going to be discussing the geometric series test. This is just one of the several tests we need to know, and this is the last unit of the AP Calculus BC syllabus. So let's start. So the test states that a geometric series is in the form so n equals 0 infinity and then a into r to the power of n, or n equals 0 infinity a into r to the power of a into r to the power of n minus 1, where a is not equal to 0. So a is the first term in the series, and r is the common ratio. And now what we have to do is, using this test enables us to know if a geometric series diverges or converges. So the geometric series, I'm just going to write it as GS, diverges if modulus of r, so the absolute value of r, is greater than 1. So the absolute value should be greater than equal to 1. Or if modulus r is less than 1, the series converges to the sum S is equal to A1 divided by 1 minus r. So these are the two conditions to see if the geometric series converges or diverges. So it diverges if the absolute value of r is greater than equal to 1, and it diverges if the absolute value of r is greater than equal to 1, and it converges if the absolute value of r is less than 1, and this is the sum which it converges to. So now let's look at a few examples. So we have to determine whether the series converges or diverges. P over 2 to the power of n. So now we have to determine whether the series converges or diverges. So we have to look to make it into the form a into r to the power of n. So what we can do is, we can write this as n equals 1 infinity, 3 into 1 over 2 whole to the power of n. So now we have our a value, which is 3, and our r, which is 1 by 2. So r is 1 over 2, and we know that 1 over 2 is less than 1. So the series converges. And now we have to find what the series converges to. Because if it converges, we have a formula. So the sum is 1, a1, which is the first term, over 1 minus r. So how do we find a1? What we do is we plug in our value. So we have n equals 1 infinity, 3 over 2 to the power of n. We know that n starts at 1 and goes to infinity. So we plug in n equals 1 into this, we get a1. So 3 over 2 to the power of 1, which is 3 over 2. So 3 over 2 is our a1. And then we know what our r value is. So the sum would be 3 over 2 divided by 1 minus 1 over 2. And that is equal to 3. Because you have 3 halves divided by 1 half, which is 3. So now we figured out that this series converges to the sum 3. Now let's look at another example. So the question states n equals 1 infinity, 3 over 2 to the power of n. We have to make it into the form a into r to the power of n. And it already is in that form, where a is just 1. So we know that our r value is 3 over 2. 3 over 2 is greater than or equal to 1. Therefore, the series diverges. Because r is greater than or equal to 1, the geometric series diverges. And to find our a1 value for S1, so we know that S is a1 over 1 minus r. We have to plug in whatever they give. So for example, in the previous example, we had n equals 1 infinity 3 into 1 over 2 to the power of n. And we plugged in n equals 1 and we got a1 is equal to 3 over 2, right? We always have to plug in the n value which they've given here as that's the first term. For example, if n was 2, we would plug in 2 here, and that would be our a1 value. So that's just a caution which we must keep in mind while finding the sum. So now let's look at another example. So we have to consider the geometric series n equals 1 infinity an, where an is greater than 0 for all n. The first term of the series is a1 equals 108 and a3 is equal to 12. We have to find what the value of n equals 1 infinity an is. So we have to find this value. So let's go about solving this. So we know that a1 is equal to 108. So how do we find the second term and the third term to find our r value? So we know that in a geometric series, the second term would be the first term multiplied by the common ratio. And then the third term would be the second term, which is 108 times r, times the common ratio. So this would be 108 times r squared. And we know that the third term is equal to 12. So now we can find our r value easily. So r squared is 1 over 9. Therefore, r would be equal to 1 over 3, which is less than 1. So it converges. And now they're asking us to find our s value. We know that a1 is 1 over 108 divided by 1 minus r, which is 1 minus 1 over 3. That gives us our answer as 162. Therefore, n equals 1 infinity an is equal to 162. So this was another example of the geometric series test applied in a slightly different manner. Okay, that's it for today's video, guys. In today's video, I introduced the first test of many tests in the last unit of AP Calculus BC. Thank you so much, and I hope you all have a great day. And please consider liking and subscribing.